Hi there, welcome back to the answers of the gradients function sheet. These are the last two on the sheet, which I'm going to go over now. The first one, you can see that this is highly positive here, therefore it starts up quite high and then it comes all the way down to a 0 point here, and then what we've actually got to do is we've got to work out approximately how far along here it goes. So what we've got to do is we have to work out from there to around, we'll say around about 50 all the way down to about 5, so maybe that's around about 55 that it goes across there, and then from it's around about 3 at that point there. So I'm going from 3 across to say 1, a little bit more than 1, so you got a gradient here of m equaling approximately 55 over from 3 to 1 about 2. So you're looking at a gradient of just a little bit bigger than minus 20. Why is it a minus? Because you're going downhill down there. So what we need to do is we need to take this all the way down to around about approximately minus 20. So it's quite a big one. So it's going to come down here, go all the way down to about minus 20, and it's going to come up. Now we need to know roughly how far up it's going to go. We know it's 0 at this point here, and it's around about, well, say minus 5, and it goes up to around 25, so it's come up 20 from there to there. Come up, well, from minus 5 it's come up 30. And how much did we go across? That's 1, maybe 2. So you've gone across here 2. So your gradient there would be about 30 over 2. So 30 over 2 is about 15, so it's going to come up to a maximum of somewhere about there. Remember, these are approximate. It has to be approximately accurate. It doesn't have to be exactly accurate. So that means that your function is going to come up here, and then we know it's coming back down again. Now we need to know how far down it's going to go. In other words, how steep this line here is. Now that's from 20 all the way to 80, so that's around about 100. And we're going across from 1 across 2, 3, so about 3, so we're going across 2. So that's actually all the way down to minus 50. This graph doesn't go that low, so what we'll do is we'll just go as low as we can. We'll just put a little arrow there, and then we know it's got to come back up again. So we've got to come back up and come through that point there, and it carries on. We'll just put another little arrow there. If we had a decent one with a decent axis, which you will get in the test, it would have come all the way down here, then all the way back up. Okay, so that's there. Notice on the actual function you have got 1, 2, 3, 4 bumps in it, and your gradient function will have 1, 2, 3. You will always have one less, and they come up to that when you actually go over the equations. Right. Here's our last one that we're actually doing, our last one over here. And so we've got these 0 points, we know that there is 0, and we know that we've got 3 0 points here, here, and here. Right, we know that it starts off up here and it's coming downhill quite steeply, so it starts off pretty steeply negative. Then it comes uphill, and at that point there is your point of inflection, where it's gone from concave up to concave down. Now we need to know an approximate guess of what that gradient is. It goes up around about 30 and across about, well, from there all the way across to there about 2. So in other words, that gradient of that is going to be about 30 over 2, which is 15. So we want it to come up to around about 15, about there. So we know it started highly negative, it's come up, gone up to around about 15, it's got to come back down again. Then we've got another negative at that point of inflection, maximum negative gradient, and it looks like it's around about, it's very close to, if that there is 2 and this one down here is 4, across approximately 2, so it's a gradient of around about 2. It's very close to 2, so it's about there. So it's a very small one, and then comes back up. Again, we've got another point of inflection here. We're going up, what's that, 2, 4, 6, going up about 6, and we've gone across from about 1 to about 3 across 2. So our gradient was 6 over 2, so it's a gradient of about 3, so it's just a little bit higher this time. So it comes up here and then back down that way. Again, our actual function had 1, 2, 3, 4 bumps in it, and our gradient function has 1, 2, 3 bumps in it. Right, I think I'll finish there for that one, and then I'll go on to the other gradient functions in a later video.